All right, hi everybody. So this is our example question today. We have two blocks on an incline. So the biggest change for this question from any other one I've done so far is this is our first time we've had two objects with forces acting on them. So because that's the case, we're now going to have two free body diagrams. And because we have two free body diagrams, we're going to have two sets of summation of forces and that kind of stuff. So let's just add an extra step to our solving, but nothing really changes too much in everything else. Our goal is to find tension. All right, so let's get after it. First and foremost, let's draw free body diagrams. So because we're going to have two objects, I'll label it 1 and 2. All right, so for object 1 right up here, let's see, we have weight going straight down, force normal going perpendicular to my surface, so surface at incline, so force normal kind of goes up at that. There's a rope involved, so there's tension. How do I know which way tension goes? Follow the rope. So in this case, the rope is going down the incline, so tension is going down the incline. There's friction because there's a coefficient. It opposes motion. Safe to assume this thing's going down the incline, so tension, friction will go boop, boop. Why is it safe to assume it's falling down the incline? I don't know. This one has more mass. Basically, that's basically all I got. Is this one has more mass, so it's probably good to know. Now, my weight here is the issue. Because we're on an incline, remember, we rotate our coordinates. So our x-axis follows our incline now, and our y-axis kind of follows the force normal. So because of this, we have those two extra forces for incline questions only. These are only for if you're on an inclined plane. That's that force perpendicular and force parallel. Basically, we're saying this force is perpendicular to the surface, this one's parallel to the surface. All right, that's all done. Now, for our second one, for object 2, its free body diagram is going to be like 99% the same. So we have weight going down, normal going perpendicular to my surface. The change is tension. Tension's on the left side, so our tension is going to be on the left side here, going up the incline, tension, and then we also have friction going up the incline. Bop, bop. Let's add in force perpendicular and force parallel. Okay, so free body diagrams are all said and done. So now let's go to our summation. So as I mentioned, two free body diagrams, two summation of forces. 1 and 2. Forces in the x equals ma, summation of forces in the y. Let's run it back. Summation of force x. All right, I'm actually going to do the y-axis first this time because it can be solved pretty quickly. Not lots going on along the y. So in the y-axis, I have two forces, that's it. Normal, perpendicular. Also, safe to assume, no acceleration in the y-axis because it's not being lifted up off the incline. So force normal minus force perpendicular equals 0. Force normal is equal to force perpendicular. And that's going to be the same exact thing over here. Once again, not being lifted off of the axis. So there's the two forces. We're Gucci. X-axis, though, that's a little different. Okay, in the x-axis, I have three forces. Tension, friction, tension. So let's write this out. Now, tension, it is moving down, but it's moving in the positive x-axis. So that's going to be positive. So I have positive tension. I have actually a positive force parallel. Negative friction equals ma. You can't forget about this parallel force. Yes, it's not written directly on this, but it is along the x-axis. And also, I'm not going to say the acceleration is 0 because I didn't explicitly say it's at a constant velocity or anything like that, which I know can get a little confusing because you're like, oh, sometimes it is 0, sometimes it's not 0. Yeah, welcome to life, I guess. For the second one, the change is tension's negative. So a positive force parallel, negative tension, negative friction equals ma. All right? So we're left with these two things, and you're like, okay, that's a lot of variables, but we actually do have some information to solve. the reason why I say that is because we have these three equations. Friction is equal to the coefficient times force normal. Force perpendicular is equal to mg cosine of theta. And force parallel is equal to mg sine of theta. And for both of these, theta is equal to your incline angle. In this case is 20. So now it's a matter of using some equations and solving some stuff out. Now, this can be very daunting. You're like, well, I got a lot of stuff here. Where do I go? Well, just take it in steps. So I'll walk you through this first one. So let's start by solving for my force parallel. Okay, so force parallel, I have this equation right here. So I'll say B block 1. Okay, so force parallel, M is 1, gravity is 9.8, sine of 20, I wrote theta, 20, okay, pop, pop, boop, 3.35 newtons, okay. Friction, okay, so friction is my coefficient times force normal. So this right here is why the y-axis is so important. Force normal is equal to force perpendicular. Oh, force perpendicular is its own equation as well, okay. So for friction, I have 2 times 1 times 9.8 cosine of 20. This gives me 18.42 newtons. So that's block 1. Block 2, same exact process, a little bit different numbers. So what this does now is the following. So I'll say 1, using this equation up here. I have tension plus 3.35 minus 18.42 equals 1A. For object 2, I have force parallel ends up being 6.7 minus tension minus 18.42 equals 2A. Right? So now it gets this, 2 equations, 2 unknowns. Here's kind of something that we understand. So these 2 blocks are directly connected. Okay? Because they are directly connected, the following can be said. Their tensions will be the same, and their accelerations will be the same. Okay? Why? Well, because they're, like I said, they're directly connected. So whatever, it's Newton's third law basically for the forces on tensions, because whatever one applies to the other, that will apply back onto it. And the acceleration is, because they're connected, object 2 can't go much faster, cannot go any faster than object 1. They're going to go the same exact acceleration. So we're going to combine the 2 equations. The way we need to combine them is we need to get A by itself. Why do we need to get A by itself? It's because I want to solve for tension. If I get T by itself, it substitutes it out. So this top equation is already done. The bottom equation just becomes this. I have A is equal to, and like number-wise, we can simplify them down. But we basically get acceleration is equal to negative T minus 11.72 all divided by 2. Okay, so here we end up going. Basically, we're simplify that equation. So basically this T minus 15.07 is equal to negative T minus 11.72 divided by 2. Okay, multiply both sides by 2. Because we don't want to get rid of the fraction, 2t minus 30.14 equals negative t minus 11.72. And simplify this even more, and we get tension is equal to 6.14 newtons. Bada bing, bada boom. Have a good one, kids.